Let's tell a few people that we are doing this right now. And let's check out day 3. Just before the stream started, I made a new class for day 3 and created part 1 and part 2 sections so that I don't have to mess around with that. I also made a few simple extensions here because if you know, I had to split the forward and the amount yesterday, and I don't like having like part 0 in my code. I like to have names for that. So what I did was write an extension that extends a string array, and you can do a .as, and then you can provide functions to transform those types. And C# is pretty smart, so you don't have to specify all these type parameters. You can just infer it from the result type of the function that you return. So I made one for 2, 3, and 4, and we'll see if we need more later. So doing that, I changed the parse code for part 2, so you can see that here. It still has the instruction .split, but it has a as, and it returns the first just as a string. So the first type will be a string, and the second part will be parsed as an integer. So this will be a key value pair of string and integer, and since this returns a value tuple, I can use like the more friendly notation and create an inline object with these properties called command, which is a string, and the amount that has the parsed value. So now the code becomes a lot cleaner, at least in my opinion. So yeah. So let's start to read part 3, day 3. Binary, okay. By the way, this black screen that pops up, it's a Python screen. It's for my Alien Worlds mission notification bot. It runs every 5 minutes, and I still need to move that to a different server. So, sorry for that. Day 3, binary diagnostic. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, your puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the condition of the submarine. Hey! Hi Richard, thanks for joining. Yeah, third time is a lucky charm. Did you do today's task already? I'm just reading it. I was just going over some extension functions that I made to make the code a bit cleaner for today when parsing stuff. Let's see. The diagnostic report, your puzzle input, consists of a list of binary numbers which, when decoded properly, will tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers called the gamma rate and the epsilon rate. Okay? The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. For example, given the following diagnostic report, you have a bunch of binary. I have, yes. Not very nice code, but it works. Yeah, usually the code doesn't end up nice, but I usually try to make it somewhat fancy. So here we have a lot of ones and zeros, or binary. So it's 5-bit binary here. Let's see, considering only the first bit of each number, there are 5 0 bits and 7 1 bits. So depending on which end you start to count, right? But yeah, 5 0 bits, so they count from the left, sure. And 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is 1. The most common second bit, okay, so you count each one in the row and see which one occurs more. The most common value of the third, fourth, and fifth bits are 1, 1, and 0 respectively, so the final 3 bits of the gamma rate are 1, 1, 0. So the gamma rate is the binary number 1010, okay, or 22 in decimal. The epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit for each position is used. So that will be the inverse, right? Yeah, it will be the inverse of this. Multiplying the gamma rate by the epsilon rate multiplies the power, produces the power consumption. Okay. Use the binary numbers in your diagnostic report to calculate the gamma rate and epsilon rate. Then multiply them together. What is the power consumption of the submarine? Be sure to represent your answer in decimal, not binary. Okay. Okay. I'm going to refactor it all at some point. Yeah. Okay. First, let's look at the input. So they are longer here. Okay, that is fine. So basically, what we have to do is actually process this. Once we know how many rows there are, and I usually read them as rows, once we reach at least half, we know what the value should be, and we can move on to the next one. So yeah, let's just see how we do this. I think I have an idea. So we have our lines is input split as lines. Can't even remember. Let me see. 2 lines. Okay. 2 lines. No, 2 lines. Let's see. Majority equals lines. So this will be math.ceiling lines.count length actually divided by 2. And we convert this to an int. And we can do int, how did they call it? Gamma and epsilon? Gamma and epsilon, okay. So we can do int gamma 0, 0. Yeah. So we can do, let's see. I'm just thinking, dictionary, int, counts. I'm just thinking, like, we go through the rows. For each row, we because we can abort early, but we don't know if we have to go for the other rows. So I'm not sure if it's more efficient to just go line by line and then all the indexes and then skip the ones that you don't need, or just go through the columns and just loop till you have them. Let's just do it the simple way. So we do int digits is lines dot first dot length. So we can do for int digit pos is 0, digit pos smaller than digits digit pos. So this is the columns, and now we go for each column. We will go to all the rows, and we will abort early if we reach consensus there. So we do, let's see, I'm just thinking, we need to keep track of the count. So we do int count 0. Actually, we can do that here. The count is 0. We do for int I is 0, I smaller than lines dot length increment I, and then we can do if lines I digit pos equals 1. Then we do count. We increment count. And we can do if count larger or equal than majority. We're done. We break. And now we can see here if count larger or equal than majority. Then we do gamma plus equals digit, no, it's actually 1 bit shifted by the digit pos, and else we do epsilon. So this should give us the no, this is inverted, right? So I need to bit shift this position minus digits. So I need to make sure that I shifted the right amount of positions. So I think this should be it. This exits early, and then we do console.writeLine. We can do name of comma. Name of epsilon. Epsilon. Result times epsilon. So let's see if I coded this correctly. And always the annoying Python pop-up. var d3 is new day 3. Did it overflow? Okay. Ah, yeah, okay. I need to go make sure they are longs. Okay, that's fine. Because we actually reached the like the first bit determines if it's a positive or a negative number. That's weird. I probably need to make this long. Haha. What am I doing wrong here? Ah, I'm doing it the wrong way around. Darn it. Okay, let's see if this is the right result. Well, answer isn't correct. Okay. Let's just try the test input for now and see what I'm doing wrong. Let's see. So let's just see what it returns here. We get 44 and 18. and they have 22 by 9. So I'm shifting it one too many maybe. Let me see. Yeah, I'm shifting it over one too many. How does that happen? Dun, 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 dun. Not even sure if this is a correct notation, right? No. No, that works. I wonder why I'm shifting one too many. Because this one, let me just check it one time. Ah, okay. Yeah, I know. This digit is the culprit because you never shifted 5. You shifted 4 to get the 4th position because it starts at 0. So this is a off by 1 error. So we subtract from digits -1, and that should give us the result. And I need to remove this. So yeah, that is correct. And now I can jump back to the actual input. These off by 1 errors are always so annoying. Boom. So yeah, that was it. I hate when I forget something like that, because you do it all in your head and it's easy to just miss something right there. So yeah, so the basic approach I took was, well, you have to find the majority. So at least as soon as you hit more than half, you have a majority. So you can stop processing there. And since the other part does the inverse, you don't actually have to do something. So I just added the bits based on which it hit. So let's see part 2. And I'm curious to hear about how you solve this later when I fix part 2 as well. Let's see, next you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Okay. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains, before searching it. Thank you, Richard. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then, keep only the numbers selected by the bit criteria for the type of rating value for which you are searching. Discard numbers which do not match your bit criteria. Okay, I have to see what the bit criteria is. I don't know if it's just flagged or not. If you only have one number left, stop. This is the rating value for which you are searching. Otherwise, repeat the process, considering the next bit to the right. The bit criteria depends on which type of rating value you want to find. To find the oxygen generator rating, determine the most common value, 0 or 1, in the current bit position and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 1. Okay. Let's see. To find the CO2 scrubber rating, determine the least. Okay, so that's the opposite. Keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 0 in the position. Okay, so you have a bias towards the one that you're looking for. So I'm pretty sure this is a scenario that exists, otherwise they wouldn't put it in there. And it's something to take into account. Let's see, for example, to determine the oxygen generator rating value using the same example diagnostic report, start with all 12 numbers and consider only the first bit of each number. Yep. So you keep those rows. Okay. Two of the three numbers have a 1, so keep those two. In the fifth position, there are an equal number of 0 bits and 1 bits, so find the oxygen generator, keep that number with a 1. Okay. So as there's only one net, stop, the oxygen generator is that. Okay. Then to determine blah, you do the same. Okay. Finally, to find, you multiply those two. Okay. So I think I'll just do 2 loops here, since it branches, right? This is branching code. So if we just look here, after the first part, you divide your allowed numbers in 2 areas, and then you move on. So my first thought would be to keep a dictionary with the indices. So I'm just thinking there are easy and fancy ways to do this, and I'm usually not looking for the easy way. So I'm just thinking if that's a good idea, because then you keep the ones with the ones, and then you filter on those. So you can just keep removing, turning off flags, and you can do the same for the other part. I'm just thinking if I can use one dictionary with a flag that goes 3 ways. Because if one can, actually no, this can be done in one dictionary, because it cannot be considered. I think it needs 3 states to have like true for the first one, false for the second one, and null for eliminated. That way you can keep looping, and if it's not the value you're looking for, you skip them. So I think that's the way to do it. So you would have a list of it's actually a dictionary, right? Well, it's all the same index base, so it could just be an array. Let's see. I can make it an array, so I can say bool, a nullable bool of length lines dot length state. Actually, I think I need to do it like this, right? Yeah. Okay, so this initializes the array. So I can do I should actually, oh, and this is per line, right? No, because you move as it goes. So yeah, okay. So here you can go, let's see. So we need to do this first. And then we can set I'm just thinking, if there is a stalemate right at the start, it should be a valid value for both sides, so that would be an issue. Because in my theory, it can only be used in one side. Yeah, the first one will shift it. But since you have to consider it the other way around from the other side when you do that, no, you can't put it in one array because there might be an issue there. Okay. So we do, yeah. Let's just do 2 arrays and have it be a simple bool, and it'll be okay. Let's see. So we have oxygen state. And we have CO2 scrub, just call it CO2 state. Dun, 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 dun. And now we can say oxygen state. And we just do this for the first one, actually. I saw delete it all and start over. No. Actually, I'm messing with part 1 here. I should probably undo this. So close, but no cigar. All right, I can do this in part 2. Just kidding, just joined, right? Yeah, I just did part 1. Just a small recap. You have this list of binary numbers, and based on the most common occurrence of a 0 or 1, you take that and put it into a value. So you build a new binary value. And for the other value, you have to do the inverse of that. So I just counted the how much you need to reach a majority, then stop counting once you reach that. And based on if it is a majority, increase the one or the other with the bit shifted value. So that you build the character one by one. So for the second part, it's a bit more tricky. It sounds easier, but it's more difficult because you have to eliminate the rows that don't meet your rules. But in a tiebreaker, if you're looking for one value, it goes the one way, and if you're looking for another value, it goes the other way. So it could be that you have one row that's part of both ways. So it's a bit of branching code. But instead, I just keep 2 state variables here. So just think in here. I do if, let's see, we always need to do the count, but only the first time we need to decide, yeah, we just do it here. No, only the first time we always have to do it, and otherwise we have to check if the line is still valid. We have to do that for each position. So what we can do is if digit pause, if digit pause larger than 0 and actually no, we always need to calculate. Let's see, because if none of the rows have this line, we can skip it, so we can just move on. We always need to do the count. Actually, we need to have a count for both, right? This is tricky because I also need to notice the amount of numbers that matches, because we reduce the amount of lines that match. So we need to actually keep track of how many there are for each of them. And so the majority also changes because it's different for both as they change. Lots more stuff to it than I thought at first. So we do oxygen majority, and we do CO2 majority is oxygen. Oxygen majority for now, but this will change as we remove some of them. Let's see. Oh, and I also can't break early here. I can't break early here because I have to know the entire scope there to know if they are to be considered. Let's see. So we can stop this one. We can just say increase the count. We don't care if it's the majority or not because we need to know the exact count. I'm just wondering if I should do 2 loops here. I love seeing someone else take a while to figure it out. It makes me feel better. Yeah. Well, in my head it was like, okay, it's really easy, but then there's lots of stuff to consider. And I could take the easy road and just write 2 loops and be done with it, but I kind of wanna. I think I might want to do this too fancy. So I'm just going through it. I'm actually building it in my head and see what I run into. But I should probably just run it here. Because in my mind I was like, I need to walk the values and I have to process each line anyway, but I can skip the ones that are not part of the number that we're looking for. The whole thing was in part 1 I could exit early to save processing time, not that it matters a lot, but I like to be efficient. In part 2 I have to actually keep looping over all of them. So the question is that the best way to do it, or should I just reduce the set of lines so I could make them into lists and just remove the ones that don't matter? Or just build a new list as we go. So that's what I was thinking. I was like, okay, I can keep it all in line and just keep the state for each line to see if it's part of problem set A or B. So let's see. And I still need to do this part. Well, actually, I don't need to do this number building because it will end up with 1 row that we can then convert into decimal. So, and we also do if count smaller or equal to CO2 majority. And then this one will move on. I'm just thinking. Actually, you need to do the count. You need to determine the majority within your set, and then you can strip out the ones that don't make it. Let me think. So actually the majority thing was still a good idea. I know, because you don't know how much. I'm thinking it might just be better to do 2 loops now. Let's see. Yeah, because I'll just grind to a halt if I keep doing this. So let's see. We have and the line set length, is this an array? Yeah. So yeah, we can do it like that. So we just do majority. We don't need to do, yeah, we need to do that for walking. Don't need this. How we do here, okay. So I'll just do 2 loops here and be done with it. Yeah, I know, but in my head I was like, this can be done in a single loop, but it gets complicated so quickly that, yeah, it's not good. So in this case, we keep the ones, else keep the zeros. So then we have to do that again. Let me see. This one can still be done, because after this we need to, okay, I'll just do a list string next round. I'll do next round is, I can just clear it actually. Let's just do it like that. So now we can loop through the lines again. Actually, it's outside that loop, so it doesn't really matter. I just think you need to change the array. I'm just doing it lazily like this, and it's okay. Bool keep ones, all that. Let's see. And then we can do next round add line. Let's remove this window. Lines I. So we can do this outside of the loop actually. And then we can do lines equals next round. Okay. To array. Majority, we also update this. Right, and the second time you go towards the other way. I really hate this, but yeah. Let's see. If lines.count, actually I can do this here. If next round.count equals 1. Then we have our result. Let's do placeholder values here. This was oxygen, right? CO2 is 1. So now we can say oxygen is, and this will actually be the lines I, convert to in32. Actually, do we have a from base is 2, right? This will be just, that will just be the next round, but sorry, next round, that first. Break. And let's just ugly copy this as well. And the only difference here is that this tiebreaker swings the other way around and you invert it. Let's see. Let's see. For the second one was the least common value. Yeah, so you do it the other way. So this would be smaller or equal to the majority. Is that correct? Because count will be the inverse and it doesn't really matter in this case, right? Yeah, that's the same. Okay. And this will be keep zeros. Actually, no. Because it still keep ones, right? You keep the 1 values if the count is lower than, yeah, okay. Okay, let's see. This will be CO2. I will have to run this on the test input because I'm not so sure anymore. Oxy, name of, this can just be CO2, CO2, oxy times CO2. And let me run this against the test input because I want to be sure that it works beforehand. Two lines, okay. Let's see. Build errors, cool. Where did I forget one? Oh, yeah, the same thing. Okay, the second one didn't work. 23 worked. And the second one should be 10, but I got 0. Okay, let's see. So the first one worked. Let's see what's wrong in the second one. Oh, I need to start off with the lines again. Haha. Yeah. My bad. The second one isn't correct. Let's see. I need to walk the second one to see if I made a mistake there. Let's see, count to 0, take it bonus. I clear this, okay. So let's just debug this one and see what I do wrong here. Okay, so we have a count of 1. Majority is 1. I also need to update the majority thing. Darn it. That's what you get when you don't properly reset. Okay. Does this change the outcome? Probably. Do I get 10 now? No, still 30. Okay, let's see. Ah, this needs to be, I'm an idiot. Smaller or equal to the majority. And then I can stop. No. Wait, let me think. Yeah, once this reaches more than the majority. Am I thinking about this correctly? Let me just run it and then. Fewer zeros, so keep only the 5 numbers with the 0, right? It says 6 here. Ah, yeah, because it reaches the majority of ones. So actually it needs to be the inverse of keep the ones, right? Am I thinking correctly that I just need to do the inverse here? Let's check. No. Okay. Let me see. It's actually, once you reach the majority, you need to take the zeros. So if I just keep this as keep ones, but that is not true, because with the majority, okay, I need to do it like this, because you only keep the ones if there's a majority. So if there's not a majority, you don't keep the ones. So let's see. Yeah, this should do it. Man, sometimes it's hard to debug and it's still wrong. What am I missing here? If for the second part, what you have to do is you keep the ones that are in the minority, right? Let's see. Let me read this again. The least common value. Keep only the numbers with that bit in that position. Yeah. So if I run this, and it says the ones are in, I need to stop this, because this condition also means that it needs to go over, right? I'm running it one more time, and otherwise I'm stepping through it. No, it's still not the right result. Let me just step through it and see if my logic works. You do not need to loop through all of them, adjust just the majority. Yeah, for the first one works, but the logic for the second one is wrong on my end. So in this one, I've went over the majority, and we want to keep, let's see, because in case of a tie, we also want to keep the zeros. So yeah, we're determining here if we want to keep the ones, and that only happens if we reach more than a majority. So this is correct. We want to keep the ones. No, but we want to do the opposite, right? Oh yeah, so then you do the opposite of it. Man. So this still determines, based on the new rules, where the equality goes the other way, if you want to keep the ones. So then we do the opposite here, because we don't want to keep the ones. So this is like the 10th time that I thought that I had it. So let's check again. And now I get 15, so that's still one too many. I'm really curious to see where I end up wrong here. So let me just step through it. Keep only the 5 numbers with the 1. Okay, so let's see, if I end up here, I should have the 5 numbers with a 1. So let's just run it this way and see if it does that. So next round, it has 5, all with the 0. Okay, so that is correct. Majority is now 3. Let's see, keep ones is false. Oh, okay, wait a minute. Because our lines are now, yeah, because there are only 2 ones here, we should actually keep the ones. We need to keep the ones with the majority. I'm an idiot. Oh, without the majority. So keep ones is false. So actually this should keep the ones then. So now we should end up with 2, right? Let's see, next round. Should have the 2 with the 1. Okay, so that is still correct. Man. So keep the 2 with the 1. Okay. So that is correct. Now it says keep ones false. Okay. What do we have here? Yeah, with the tiebreaker we should go for the 0, right? That's what we have. Which one is I? I is 0. Wait. Let's see. Keep ones is false. Which is I, 0, okay. That's weird. Wait. This one should be true. Don't need that one. So this one is true, but keep ones is false. So if trues does not equal false, why does this one hit? Am I crazy? This should be false, right? Wait, what? True. False. Ah, we want to actually, okay. I say do the opposite here, but we still have this rule. So the tiebreaker is wrong. Let me see. So this one should still say, right? Let me just run this to completion because I think this one should be it. Just the 8th time that I think I got it. Yeah, that's it. Oh my God. So something so simple can be become so complicated. So yeah, the issue is that we still have to keep this part. So the tricky part is you have to do the opposite, right? In the first part we had a, in case of a majority or equality, we want to set a 1. So that was simple. And I had a loop that would stop counting as soon as we hit equilibrium, or so as soon as we hit the tie, it would stop processing. For the new rules, the tie goes the other way. So what we want to do is make sure that there is that if there is no tie, that we know that. So we do it this way. So we have to go until we pass the tie, then we can actually stop looping because we know that the tiebreaker was won by the other side. In the actual logic here, we still keep it the same. We determine if by the logic we should have done the 1 and then do the inverse because we want to keep the minority. So yeah, this was not clear, and I probably should write this in a different way. Because I thought I could do a quick adaptation and fix it, but no, this is just... you can see how easily it is to trip yourself up. Let's run this on the real input. This still needs to be here. Pooh. And now we have it. Wow. Yeah, the second part took me way longer than it should have. way longer than it should have. But it's the kind of stuff that I like because it makes you think and trips you up. And yeah, I'm just thinking now about what I could have done better or differently. Because you still have to look for one or the other, determine if there's a majority, and then keep the minority. So I don't think there's much that I could have done differently here. Thank you. I'm really curious to see how other people solve this, because in my original idea was, but that didn't account for the tiebreaker going, the tiebreaker being able to do two parts, because I thought, well, actually, if the first part isn't a tie, it would still work with just keeping one tracking variable. I'm really enjoying this here. Yeah, me too. I'm having fun. I'm having fun. It's I'm just a bit disappointed that it took me so many times to get the logic for this one correct. That's yeah, not ideal. Do you think of a way that I could have done this better? Do you mind if I look at your code on stream, or do you prefer me to do that off stream? I have you here now, so I can talk to you. What I usually do is after it's time to go to bed, I watch a few of the other people that upload to YouTube and see what they did, see how they approach it, where they struggle, or which innovative ways they manage to fix some of this stuff. Yeah, I'm having fun. So I guess I'll close it here for now and go look at how other people did it. That's mine. If you post a link, YouTube swallows those. I still have your... I can pull it up if you don't mind. Let me see. I have it in the Twitter DM. Let me just check. Boom. Let me see. Calculate answer part 1. So you just count all of them. Determine majority. Okay. That's the thing about JavaScript. It implicitly converts this to a string, but I would always put like quotes around it here. But it's discussing code, so to prepare yourself. No, man, it's no worries. Especially in stuff like this, it's getting the answer is the most important. But I always try to do it in a nice way. But I didn't succeed today. Oh yeah, like the. It's so nice when you can have, how do you call it? The parsing with the radix, that you can just set, oh yeah, this is binary, parse it for me. I went the bit shifting route. Actually, for the other part, because I only had the end result as a string, I did the same, right? Let's see, CO2 input. Yeah, so you duplicated the inputs there as well. Determine the length, yeah. Also count the ones. If there's a majority, sure. You use a JavaScript filter. Well, that's actually smart. Didn't think of that. Let's see. Yeah, and so here you count the majority, minority. Yeah, actually this is cleaner, I think. This is more readable than what I did. So but you also went the other way to count the zeros, right? Yeah, okay. Yeah, I think this is more readable than what I did. Because there's nothing in here that really trips me up. I can follow the flow and understand it, while I have a bunch of exclamation marks to invert logic, right? For like, in here, you invert the logic. And that's stuff that and because you talk about the ones, but you actually, yeah. Yeah, I think your way is cleaner, easier to read. So, well done. I'll try to do better tomorrow. Well, I had fun, and thanks to everybody that stopped by and saw me struggle. Let's see what tomorrow holds in store for us. So thank you for watching, and glad you could stop by, Richard. Maybe see you tomorrow as well. Bye bye.